everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. आज हम लोग प्रिंसिपल ऑफ प्रोग्रामिंग लैंग्वेजेस की क्लास करने वाले हैं, जो कि क्लास नंबर 7 है। ऑलरेडी हम 6 क्लासेस कर चुके हैं, जिसमें हमने यूनिट 1, यूनिट 2 एंड यूनिट 3 स्टार्ट कर दिया है। यूनिट 1 यूनिट 2 कंप्लीट भी कर चुके हैं एंड यूनिट 3 हमने स्टार्ट कर दिया है। एंड होपफुली अगर ये ज़्यादा लंबा क्लास नहीं जाता है, सो आई विल एंड अप हियर ओनली। बट बिफोर दैट, फर्स्ट ऑफ ऑल, इट्स अ ह्यूज रिक्वेस्ट फ्रॉम माई साइड टू ऑल द व्यूवर्स, please go through with the subscribe button and please like, share and subscribe to our channel so that many maximum people can get the information at once, and even though you can also enjoy the video as well. And they're talking about unit 3rd, which is your programming paradigm. This is the unit name. Now we'll discuss about it, and that the last we had discussed about the features of object oriented programming that we had done here. So it's a huge request from my side, so please go through with the subscribe button and please like, share and subscribe our channel. Let's go ahead with the headings, that the topics that what we have to discuss here, which is the first topic. We'll discuss about basic concepts of object oriented programming. In the basic concepts of object oriented programming, where we'll discuss many more things in a detail as well. And this that there is a that has been asked of 10 marks, and there is a single motivating factor behind the object oriented system that development, and that is it is a desire to make a software development easier and more natural by raising the level of abstraction to the point where the application that can be implemented in the same terms in which they are described by user. And it is necessary to understand some of the concepts used extensively in object oriented programming, and these includes the first we have here is your that is objects. In the terms of objects, a car is an object, a real world entity, and identifiably separate from its surrounding. And a car has a well-defined set of attributes in relation to other objects such as color, manufacture, cost, and odor, and as well as that defined set of things you normally do with it, like drive it, look it, tow it, and carry the passengers in it. So the objects are being runtime entities in an object-oriented system. They may represent a person, a place, a bank account, table of data, or any atom that a program has to handle. And they may also represent the user-defined data such as vector, time, and list. A programming that is your programming problem is analyzed in the terms of object and the nature of the communication between them, where the program object that should be chosen such that they match closely with the real-world object, and the object takes up space in the memory and have an associated address like a record in Pascal or a structure in C. When a program is executed, the objects interact by sending message to each other. For example, if the customers and account are two objects in a program, then the customer object may send a message to account object requesting for a bank balance. Like each object contains the data and code to manipulate the data. So object can interact with having to know each other data or code, and it is sufficient to know that the type of a message accepted and the type of the response returned by the object as well. Well, the second one we have here, that is in the terms of it, in terms of object oriented programming, that includes the second is your that is classes. In the terms of the classes here, that a class is a blueprint of an object. That is, all objects are the instance of a class, and the classes are used in object-oriented programming to define the data and the method that the object will contain. The method invoked by an object in response to a message is determined by a class of the receiver, and where all the objects of a given class that use here and that use basically the same method in response to the similar message, where classes are very useful in programming. And consider the examples of where you don't want to use just one person but 100 people here. Rather than destroying each one in detail from scratch, you can use the same person class to create 100 objects of the type person. That is, once a class has been defined, we can create any number of objects that is belonging to that class, and each object is associated with the data with the data of the type class with which they are created. Even though a class is thus a collection of objects of similar type, and for example, like mango, apple, and oranges are the members of the class fruit, and where classes are user defined data type and behave like the built in the different than the syntax used to create an integer object in C. In a fruit has been defined as a class, then the statement fruit mango will create an object mango belonging to the class fruit here. So that is the variable states as well as the method that can talk about the as in the form of behavior as well. The third one we'll talk about, which is your data abstraction and encapsulation. Data abstraction and encapsulation. So in data abstraction and encapsulation here, where the data abstraction, also known as data hiding, in the mechanism whereby the implementation detail of a class that are kept hidden from the user, and the user can only perform a restricted set of operation on the hidden members of the class by executing a special function that commonly called the method, and while the data encapsulation that refers to a wrapping up of data and method into a single unit as well. Now we'll talk about the fourth one, which is your inheritance. In the terms of the inheritance here, that is, the inheritance is the process by which an object of one class acquire the properties of an object of another class. It supports the concept of hierarchical classification. For example, that the bird like robin is a part of the class flying bird, which is again a part of a class bird, and that the principle behind this sort of division is that each derived class shares a common characteristics with the class from which it is derived as well. Like birds है तो like उसके attributes like feathers, lays eggs, so they are flying birds, and the non-flying birds, they had been divided, so their attributes are different. In the flying bird that comes robin and swollen, that is a property of the inheritance, and of course non-flying bird we'll talk about the penguin. So that is a flow chart like a tree form. Now we'll talk about the another one, that is in this reference towards this only with the inheritance, that in OOPS that the concept of inheritance provides the idea of reusability, and even though this means that we can add additional feature to an existing class without modifying it, and this is possible by deriving a new class from the existing one, and the new class will have the combined feature of both the classes as well. Now talking about the another one, which is the fifth one, which is polymorphism. In the term of polymorphism, the polymorphism is the another important OOP concept, and polymorphism, a Greek term, means that the ability to take more than one form, an operation that may exhibit a different behavior in a different instance, that the behavior depends upon the type of the data that is used in the operation. For example, that consider the operations of addition. For two numbers, the operation will generate a sum. If the operands are string, then the operation that would produce a third string of concatenation, and the process of making an operator to exhibit the different behavior in a different instance, that is known as operator overloading, where that a single function name that can be used to handle a different number and a different types of argument. This is something similar to a particular word having a several different meaning depending upon the context, and using a single function name to that to perform a different type of task, that is known as function overloading, and that a single function that name that can be used to handle a different number and a different type of argument as well. This is something similar to a particular word having a several different meaning depending on the context, and then using a single function name to perform different types of tasks, that is known as function overloading. We'll talk about that shape draw that has been circle object, box object, triangle object, and that comes under in it that will draw a circle, will draw a box, will draw a triangle, so that is comes under under the shape only, and that is the polymorphism is all about. In the polymorphism, plays an important role in allowing the objects having a different internal structure to share the same external interference, and this means that a general class of operation that may access in the same manner, and even though the specific action that is associated with each operation that may differ, and polymorphism is extensively used in the implementing inheritance as well. So after that I will talk about it, and here that is the sixth one after the fifth one, which is your dynamic binding. In the dynamic binding here, that the binding refers to the linking of a procedure call to the code that to be executed in the response of the call, and the dynamic binding also known as a late binding. That means that the code associated with a given procedure that call is not known and until the time of the call at runtime. It is associated with polymorphism and inheritance, and a function call associated with a polymorphic reference that depends on the dynamic type of that references. Like consider the procedure like draw, that by inheritance that every object will have this procedure and its algorithm is however unique to each object, and so that the draw procedure will be redefined in each class that defines the object at the runtime, and the code matching that the object under the current reference that will be called as well. Now I'll talk about the seventh one, which is your message passing. In the term of message passing, an object-oriented program that consists of a set of objects that communicate with each other, and the process of programming in an object-oriented language. Therefore, that involves the following basic steps. The first, that is to creating a class that defines the objects and their behavior. The second, that creating objects from the class definition. And the third, that establishing the communications among the object as well. In the same cases, that the object that communicate with one another by sending and receiving the information much the same way as people pass message to one another. And the concept of the message passing that makes it easier to talk about building systems that directly model or simulate their real world counterparts as well. And a message for an object is a request for execution of a procedure, and therefore will invoke a function which is procedure in the receiving object that generates the desired result. And message passing involves specifying the name of the function and the information to be sent. Like for example, like employee's salary, which is name, and that is your object, and the information as well as the message comes under in it, and that comes under known as message passing here. Now we'll talk about with the another one that is in the detail, and that is talked about it in the term of what is the difference between the abstraction and encapsulation, which is very important, and even though which has been asking many times in the examination paper as well. So let's go ahead to discuss about difference between abstraction and encapsulation. So here we'll go ahead with a difference between abstraction and encapsulation. Difference between abstractions and encapsulations here, that we are going ahead. In the differences between, there are many differences, but we'll discuss about 3 to 4 differences, approximately 5 differences between those. The first we have that is the differences as the abstraction solves the problem in the design level, that the abstraction process has been solved in the design process, and that even encapsulation that solves the problem in the implementation level as well. Talking about the second difference, where the abstraction is used for hiding the unwanted data and giving relevant data here. So basically the encapsulation means hiding the code and the data that into a single unit to protect the data from the outside world here, that is encapsulated. And in the same case, the third one we have is your abstraction lets you focus on what the object does instead of how it does it. And encapsulation means that hiding the internal detail or mechanism of how an object does something. Where these were the some thing which is different from one another. Here it is needed that what is required of that you have to be known, and here that how does it work, how does it performs, that is your encapsulation. And that is of the fourth difference, the abstractions outer layout user in terms of the design. For example, the outer look of a mobile phone, like it has a display screen and a keyboard, that is keypad buttons to dial a number, that is comes under the abstraction. But in the encapsulation one, that the encapsulation inner layout used in the terms of the implementation. For example, the inner implementation detail of the mobile phone, how keypad button and display screen are connected with each other and using that circuit, that is comes under the known as encapsulation here. Now we'll talk about another one, which is that is your explain the standard input and output streams of C++ language. The standard input and output streams of that C++ language, that what we have to discuss here. In the same cases that even though we had used in C++ language, that we are dealing with here as well. And in the same case that a stream in an object, that we are a program that can either insert or extract the character to or from it, and that the standard input and output stream, that object of the C++ that are declared in the header file stream as well. We will talk about that the standard input stream first. So in the term of standard, that is input stream, for inputting the keyword sin, that cin is used here, and which is an object, and the overloaded operator of the extraction, and that is in the standard input stream in the case of sin stream. So a single sin statement is as to be follows and has been represented in the form of is as same as like sin theta x and sin, that is y here. So here that is in both of the above cases, the two values are input by the user, and the one value for x and the other for the y as well. So let's go ahead to discuss about the second one, and which is your standard output stream. The standard output stream here for outputting the values of the keyword count, the cout is used, and which is an object, and the insertion operator that is used for the standard output, that is cout stream, and the syntax for using the standard output stream is cout followed by an operator, and that followed by the value that to be inserted or output by the insertion operators as well. So for that, if for example for this we have cout, like for example that is your the subject is ppl, so like ppl, and so this gives an output as ppl. Again, if you write principle of programming languages, so it will give you as output principle of programming languages, so that will give here. Now we'll talk about another one, which is what do you mean by the constructor, and discuss its type. So how constructor is used and what are the types, that what we have to discuss here in the detail. So in the constructors and the types of constructor here, what we have to discuss in a detail. In the terms of the constructor, a constructor is a member function with the same name as its class. And for example, consider a class X. So then we will be having class X public, and then the constructor for the X, and the constructor that are used to create and that can initialize object of their class type. It cannot be declared virtual or static. Moreover, it does not have any return type. And the types of constructor, if I'm talking about, the first we have your default constructor. In the term of a default constructor, this constructor have no arguments in it, and it is also called as no argument constructor as well. So for this, we will be writing up for example like a program that you can understood about it with a different pen, so that you can get to know about it as well. That is like class BTech start private and a comma b public, that is BTech. This is the default constructor, then closing tab. This is for the default constructor here. Talking about the second one, which we have is your that is parameterized constructor. In the parameterized constructor here, we will be talking about, so that is this constructor takes an argument. For example, here only that will take it class BTech start curly bracket int m comma n public, that is BTech int x comma int y. This is parameterized constructor. Then we have BTech int x comma int y, m equals to x, n equals to y. So here we must pass the initial values as arguments to the constructor function when an object is declared, and that the explicit call that can be declared as in the form where we take b1, that is btech 0, 100, that the implicit call is implemented as btech b1, that is 0, 100 here. Now we'll talk about the third constructor, which is the last constructor, and that is termed as the copy constructor here. In the copy constructor here, where this constructor takes one argument, and it is also called an one argument constructor as well, and that the main used in to initialize the object, while in creations also used the copy an object, and it also allows the programmer to create a new object from an existing one by initialization. And for that, for example, that to invoke a copy a constructor that the programmer writes here, so that is in the form of btech b3 b2 or btech b3 equals to b2. So this is how it used as a constructor, that is a copy constructor here. Let's go ahead with another one, that is, here we have to discuss what is Destructor. These were the constructors, so now we'll discuss about the Destructor as well, and that is also an important one. Let's go ahead here. Talking about the another one, which is your Destructor. In the term of the destructor here, that the destructor are used to deallocate memory and do other cleanup for a class object and its class members, and the object is destroyed, and a destructor is called for a class object when that object passes out of scope or the explicitly deleted, and a destructor is a member function that with the same name as its class prefixed by tilde as well. And for example, for that we will be using here that is in the form of the destructor of x as well as the constructor for the x as well. So let's go ahead to do that as well, which is your class x, then public. This is the constructor of x, destructor of x, and that is the curly bracket close, and that has been the destructor has been the following properties that they should be followed. And that is, the first is that destructor takes no arguments and has no return type, and it addresses cannot be taken, and the destructor cannot be declared a constant, volatile, and the constant, volatile, or static as well, and a destructor that can be declared virtual or a pure virtual as well. That the use of the destructor is suitable when an object assigned a dynamic memory during its lifetime, and at that moment of being destroyed, we want to release the memory that the object was allocated as well. So the class members that are class type that can have their own destructor, and both base and the derived class that can have a destructor, and although that the destructor are not inherited, and the destructor of the base class and the members that are called in the reverse order by the completions of their constructor as well. Now we'll talk about in a detailed about it. That is another question that has been asked as we discuss the friend function in detail. So that what we have to discuss here. Terms of friend function here. So we have friend function. A friend function is used for accessing the non-public members of a class, and a class that can allow non-members functions and the other classes to access its own private data by that making them friends. Thus a friend function is an ordinary functions or the member of the another class. The friend function is written as any other normal function except the function declarations of these function is preceded with a keyword friend, and the friend function must have the class that to which it is declared as a friend passes to its argument. Where we'll consider a class that to understand the friend function, which is we'll go ahead here. That is class BTEC. Private int a comma b, public void test, a comma 100, b equals to 200, and the friend int that will go ahead with friend int compute, which is btech b1, int compute btech b1. That is your friend function definition, which has access to the private data, and that is return int b1a plus b1b minus 5. That is main. Here that is in the case of main, btech b, btech that is b test, then count, the result is compute b, and this is the calling of the friend function with an object as an argument. Then we'll close the tag as well. So here the output is that the result is 295. result equals to 295 here. So this is that the function compute is known as non-member functions of the class VTech, and in order to make these functions have access to the private data A and B of a class VTech, it is created as a friend functions for the class VTech as well. Let's go ahead to discuss about it, which is to describe virtual function and also explain pure virtual function as well. So let's go ahead to discuss about virtual function. In the term of the virtual function, that the concept of the virtual function is as same as a function, but it does not really exist, although it appears as needed place in the program. And the object-oriented programming languages, that is C++, that implement the concepts of virtual function as a simple member function like all members functions of a class, then the functionality of a virtual function that can be overridden in its derived classes, where the properties of the virtual function, if I'm talking about here, that is we'll be having the properties of virtual function. In the terms of the properties of virtual function, where we have the dynamic binding property. Virtual functions are members functions of a class. They are declared with a keyword virtual, and it takes a different functionality in the derived class as well. We are in the same cases, we'll talk about it, and that is, for example, that the general syntax that declares the virtual function that uses. So with respect to that, the class name will take about. Class name, which is the base class of C++ virtual function. Start with that. Public virtual void member function name. This is the C++ virtual function. So here the pure virtual function is a virtual function with no body, and since it has no body, the programmer must add the notation equals to 0 for the declaration of the pure virtual function in the base class, and the syntax of the pure function that takes the form here. So we'll talk about it, which is pure function, that is virtual. So here with the pure functions that we'll talk about it. Class name, which is base class of C++ virtual function. Public virtual void virtual function name equals to 0 here. So that what will go ahead. So here we'll discuss about it, the function programming, and that the functional programming. In the functional programming, focuses on what is a heavily listed oriented and that list oriented, and the type system that presents the occurrence of the execution error during the running of the program, that curried functions returned function as result as well, and the abstract data type that provide the feature of abstraction as well. So let's go ahead here. That is functional programming. In a functional programming here, in the terms of it, that the functional programming is all about expressions, and the other way to describe the functional programming that might be in the terms of the expressions oriented programming. And since in the functional programming everything that reduces to an expression, The functions are just as objects in a functional programming. That is, they are often passed around within a program in much the same way as other variable. And the idea of passing function that around the program is the key of the functional programming, where the functional programming tries to focus on the what rather than how or a problem solving, and a functional program that should describe the problem that to be solved rather than focuses on the mechanism of solution. A pure functional program is structured by defining an expression which captures the intent of the program, and each term of the expression is in the term of a statement of a characteristics of the problem, and the evaluation of each of these terms eventually yields a solution as well. Where Haskell is the language that which is uses the concept of functional programming. Example, like consider the task of the calculating the sum of the integers from 1 to 10 and using the imperative language. So that total equals to, let's go ahead here as well. Total equals to 0. For I equals to 1, I is less than equals to 10, and I plus plus total plus equals to 1. In a functional languages of the same program, that would be expressed as, and the sum is still from 1 to 10, that it gives as an output. Now we'll talk about the another one, which is to describe the differentiality transparent expression. So differentiality, a transparent expression, that what we have to discuss here. In the terms of a differentiality transparent expression, an expression is a differentiality transparent if any sub-expressions and its value that can interchange without changing the value of expression, and this is not the case if the value of an expression depends on global state, which can change value. For example, if y is a global variable in that, so here we'll go ahead with this, and that is your fx return x plus y g of z, a equals to f of 1, y equals to y plus 2, return a plus f of 1, then closing. So here the pure functional languages that achieve differential transparency by forbidding the assignment variables, and each expression is a constant or a function applications whose evaluation has no side effects, and it only returns a value, and the value that depends only on the definitions of the function and value of its argument as well. In the same cases that we deal with it, and we could make a differentiality transparent by passing in y as an argument, which is fx comma y, which is x plus 1. So the differentiality transparent that programs are more related to the formal methods and easier to reason about, because the meaning of an expression that depends only in the meaning of its sub-expressions and not the order of evaluations of side effects of the other expression as well. We'll talk about in a detail here as well, and that is comes under in it, which is we'll have to discuss about describe the type system in detail. So let's go ahead to discuss about it. Type system here. In the talking about the type system, we will talk about it, and that is the functional that fundamental purposes of the type system, that is to prevent the occurrence of executions errors during the running of a program, and the type system that act as an aid to modeling by the provision of set of as regular interpretations of the patterns in a type system that provides a mechanism by which the inappropriate applications of operation is prohibited. Thus, a type system is regarded as a provider of both modeling and a protection within a programming system, and a language whose type system that prevents any operation which violates its modeling facilities is referred to as a strongly typed language, because before strong typing is enforced here. So in that same case in a programming languages, that the designer must be confident that the modeling provided by the type system is adequate for a language purpose, and if type system modeling is inadequate, then the programmers are forced to use an inappropriate type modeling, where an operation which violates a model that provided by a type system that may be detected at any time before the operation is executed, and it is desirable to detect such errors as early as possible due to the two reasons. The first we have is your program safety, second is your program efficiency. In the same cases that these type systems that are viewed as mechanism, and which imposes the static safety constants upon a program, and the data manipulated by a programming language is governed by the language type system as well. We are talking about another one which we'll have to talk it about, and that is comes under in it, that is what you mean by the scope rule for names. Scope rules for names. So in the scope rules for the names here, the names in the programming languages that can denote anything, including the constants, variables, type, and procedure, and a declarations of the name introduces a new sense in which a name is used, where the scope rules of a language determine which declarations of a name X applies to an occurrence of X in a program. That, for example, the variable a, that is integer, shows that a variable a is of type integer, and the other two kinds of the scope rules are, the first we have is that is your lexical scope rules, and that is your also known as a static scope rule, and that the second one we have a dynamic scope rule. So in the static that is your the lexical scope rules or a static scope rule here. In this, the following example that is shown as an f hash function, and the function for uses the variable x to calculate a result, and the value x that will be defined twice with a different content. The first value for x that will be the set where the function for is created, and then x will be changed where the function is for is called as. Let an example 1 here. In that same cases we'll be going ahead to discuss about it, which is your let x equals to 1, that 4, y equals to x plus 1 y, and let x equals to 2, so 4 equals to 5. So if you execute the example, it will return 6, and because f hash uses the lexical scope, and whenever a function is called, it uses the scope, that is the environment where the function that was created. And in the example that we have take two scopes, one where the function is created and one where the function is called. In the first scope of the variable x is equal 1, and in the second scope that x is 2. Therefore the first scope is x equals to 1 that is used, and an example function returns 6. So let's validate the behavior by creating a second example, like the example we have, and which is equals to here, that is let x equals to 1, let for y equals to x plus y, let x equals to 2, let bar y equals to x plus y, and 4 5 plus bar 5. So this is an example of a function return 13, because 4 is executed in the first scope with x equals to 1, and the bar is executed in the second scope with x equals to 2 as well. But why do we have created an example which uses a function which is executed by the other function as well, and would not it be easier to use the function following source code as well, where we'll say as that let x equals to 1 as well, and then of course let for y that is y equals to x plus 1, let x equals to 2, then your 4 will be equals to 5 here. So yes, of course this is an example, it's similar and easier, but it has a big disadvantages. It will be results in the compiler error, and that f hash compiler that shows the following error into a line 3 duplicate, and that is duplicate the definitions of value of x, and this is because of the main scope, and then f hash function application, and as always a single scope here as well. Therefore, it is not possible to create a second scope of the compiler that will allow the redefinitions of the variable as well. Let's go ahead to discuss about the dynamic scope here. Talk about dynamic scope. In the dynamic scope, in the contrast to the lexical scope, that the dynamic scope always uses the environment and where the function is called, and let users the first example to explain the behavior of the functions in a dynamic scope here. So that I will go ahead as well, which is let x equals to 1, let for y equals to x plus y, let x equals to 2, and 4 equals to 5 as well. So here if we execute these functions in a language which uses a dynamic scope, it will return 7 because the actual scope will be used where the function is called in the scope x is 2, and therefore the result is 7. And but the dynamic scope behavior that has some major disadvantages. For example, the readability of your source code that will decrease, and it would be very difficult to find it out. Within this short examples, you don't have to you have these disadvantages, but what if the function score is created somewhere and else in the application, and in this case you must know that the variable x is used in this function, otherwise you cannot use this function correctly, or you can even create an error because you create a variable x and which you want to use in your scope, and but you have the side effects with changes of a function behavior because then new value of x is also used as a function call as well. Let's go ahead with the discussion or more about it, and that is to discuss the type and value binding as well. Type and value binding. In a type and a value binding here, that the values are assigned to variables that may be used in an expression to stand for the value, and the values are bound to the variable using the value binding. And once a variable is bounded to a value, there is no possibility of changing the binding of a variable after it has been bounded. The types that may be bound to type variable using the type binding, and the type variable so defined stands for the type bound and that to it, and that can never stand for any other type as well. Where a binding either value or a type that introduces a new variable that is distinct from all the other variables of the class for use or within its ranges of the significance or the scope. Any type that may be given a name using a type binding, for example like type float equals to real, and type count equals to int, and average equals to real as well. And in the same case that the type binding introduces the one or more new type variables simultaneously. That's simultaneously in the sense that the definitions of the type variable that may have involve any of the type of variable that being defined, and the syntax for the type binding for the type variable a1 and type 1 and variable n that is type n. Of course that where each variable 1 type is a type variable and each type n is a type expression. So value variable that are bound to the values using the value binding, for example val m that is int equals to 3 plus 2, and val pi equals to real which is 3.14, or e equals to real that is 2.17 as well. The syntax of the values of the binding in the var that is the value and variable of 1 type 1 expression 1 and till variable n that is your first type n expression n. where each variable one is a variable and each type one is a type of expression and each expression one is an expression. So value binding is other types, and that is checked by the comparing the type of the right hand side with the specified type to ensure that they coincide, and of course that if mismatch occurs, the value binding is rejected, and the purpose of binding is to make a variable available for use with its scope. And in the case of the type binding, we may use the type variable introducers by the binding in the type expression that is occurring with its scope as well. Now we'll talk about the another one, which is what is that is your curried function. It is what is curried functions here. So here that the curried functions that are in the terms of it that are the reasonable tools for the functional program and to request, and that can encode as well, and that can encode that even though that can encode any curried function that using the just subset of the standard machine language. And in the same cases, for example, for this we have fn x that tends to fn y, and that is x. So this is a way of defining a curried function that leaves the problem of deciding it a newly defined function that should be expressed in the terms of the curried form of or takes a tuple as an argument. A simple example of a function that which turns a function as a result in the functions which when you know that the function f return to the function and which applies f to an argument and then applies to the f to be the result as well. And the standard machine language implementations of the twice function is the value that will represent it in the form of that the value and twice, that is fn functions of f that tends to x and that ffx as well. And twice is an identity function. It implies its function argument as a number of times as well. For the iterations, we define that the iter function and it is curried function which return a curried function as its results, and we have f functions that is equals to id and the identity function as well. So where when n is positive, and we have here, and that is we'll go ahead with the function formula fn fx equals to fn minus 1 of x here. So iter function that can be implemented in a machine learning that we have here in the same cases, which is equals to val res iter equals to fn 0 fn f fn x x. So here n tends to fn f fn x f iter n minus 1 f of x, and that is now we'll discuss about it in a detail, which is you describe the list along with the arrays to construct the list as well. So here talking about the list, I will talk about it. In the terms of the list, that list are used to group a number of elements, and those elements that should be the same type, and a number of the list of the same type that can be stored in list, so that they will get the list of integers, booleans, etc. And the several ways to construct the list are: the first we have enumeration. In the terms of the enumeration, enumerations of the element is the easiest method to build a list, and that the element that must be of the same type. For example, like we'll be having in the form of 1, 2, 3. So we are in the same cases that we have int. This is your 1, 3, 7, 2, 8, which is equals to int. Here it is true, false, true, and that is your bool. Now we'll talk about the second one, which is the second we have here is your as follows. That is the second one we have as your construction using operator. Construction using operator here, which is it is another way of to build a list, and this operator puts an element in front of a list as well, and as a result that makes a longer list as well. For example, if this is a list like 3, 4, 5, then 1 and x of s, that is a list 1, 3, 4, 5, that using the empty list and the operator that we can construct a new list as well. Now we'll talk about the third one, which is your numeric interval. In the numeric interval, that the third way to construct a list in the interval notations, and that the two expressions that with the dots that between and the square bracket that's surrounding them as in the reference towards it. Now I'll discuss about in a detail, which is your what are the user defined types of ML. User defined types of ML. So here the first we have is your enumerated types. Enumerated types, it has a finite numbers of the element which can be enumerated. For example, if we want a new type of a primary color that with just 3 elements that is corresponding to the red, yellow and blue, it would be constructed as in the form of, that is we have that represented in the black pen. I think that is better. Data type, primary color equals to red, yellow, blue. That is data type, primary color, that is corn, red equals to red, that is your primary color. That is your corn, yellow equals to yellow. Which is your primary color. Then corn blue equals to blue. The second we have here is your recursive data types. In the recursive data type, that we can use any value type that we have used in the process of defining, and for example that the standard definitions of the binary tree, which contains the integers as its node, that would be the first we have the every tree is either empty, that is containing nothing, and every tree is non-empty, that node consisting of an integer that is along with the two subtree or a child node as well, and that can be expressed in the machine learning to be as follows here, which is data types, int tree equals to nil, the node of int tree int data type entry, that is cornel equals to nil, entry, con node, that is equals to fn, which is ent tree, ent tree, ent tree. The third one we have here, that is polymorphic data types. Polymorphic data types here. So here that these data types are used when the basic structures that remains the same with the little differences in the type variable. For example, in the definitions of an end tree, and that the end component that can be of any type using a type variable like that is your general type of a binary tree that looks like of, and that has been represented in the form of data type a tree, which is equals to nil, node of a stick, that is a tree, abstract a tree, data type a tree, cornel equals to nil, tree, and that is con node equals to fn, which is a abstract a tree, abstract a tree, that is a tree as well. So this is talking about all about in the PPL, which we had completed the unit 3rd here, and in the next coming class we'll start with the unit 4, and that is your another unit which we'll talk about in the next coming class, which is the other programming paradigm here. And this is the unit 3rd, which is your programming paradigm. So first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In the terms of it, if I'm talking about the first unit we had covered up here, so that is the first unit is your introduction part, and where we had covered up in the introduction, and the second unit we had completed, and third unit in this class we had completed. In introduction part we had completed the introduction, the role of the programming languages, why study programming languages, as well as that towards the higher level languages, programming paradigm, programming environment, language description, syntactic structure, language translation issues, programming language syntax, stages in translation, formal translation models as well. In unit 2, that is your language properties, we had covered up the language properties, modeling language properties, elementary data types, encapsulation, inheritance, sequence control, subprogram control as well. In unit 3rd, we had covered up the programming paradigm, which we had covered up in this class, which is programming paradigm, imperative programming, statement types, procedures, activations, object-oriented programming languages, that is grouping of the data and the operations, object-oriented programming, functional programming, elements programming in a type language, programming with a list as well. In the next coming class, we'll start with unit 4, that is your other programming paradigm, where we have to cover up the other programming paradigm, logic programming, concurrent programming, network programming, language description, semantic methods as well. In unit 5, we have to complete the lambda calculus, which is a lambda calculus, introduction to the lambda calculus, simple type and subtyping as well. That is the last unit, and this is your 5th unit which we have to cover up here. So first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well, and you will be provided each and every video where we have completed the data warehouses, even though the PPL, that is principle of programming languages, we are near about to complete it, and that is your managerial economics as well we are doing, reasoning we are doing, quantitative aptitude we are doing, computer graphics we are doing, and computer networks we are doing. So you can go through with that through the playlist, and you will be getting each and every video there. So thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.